Hello and welcome. Today we're going to learn Lua. So what is Lua? Lua, it's a scripting programming language. It's similar to Python in some regards. So if you have used Python in the past, you will see that, especially in the syntax, there are a lot of similarities, but there are still some aspects of Lua that make it quite unique and different than other languages. One of these is that Lua is very minimal and simple. So Lua has been designed to be a very easy to learn language. So if you're a beginner programmer, learning Lua is probably a really great place to start. Lua is also dynamically and weakly typed. This is what makes Lua different to Python, for example, is the fact that Lua's type system is much more permissive. You can actually do really crazy and cool stuff with Lua that would usually not be possible in statically or strongly typed languages, and we will see what this is beneficial but at the same time a little bit dangerous. The main feature about Lua is that it's actually designed to be an embeddable language. This means that Lua programs usually don't run in isolation, they don't run as standalone programs, they actually run on a larger context. They actually are run to configure or extend a larger C or C++ application. This is why Lua is very popular in games. So I used to customize my World of Warcraft UI back in the day in Lua. My editor that I'm currently using is also configured in Lua. So essentially Lua is very useful when it comes to extend existing applications as opposed to being its own a standalone program. And it was created in the 90s in the PUC in Rio de Janeiro. So let's start with the classical Hello World example. So this is how Hello World looks like in Lua. String literals can be constructed by either double quotes, as you see here, or by using single quotes. So, and actually in Lua, the Hello World example has an alternative syntax, so you can write Hello World also by omitting the parentheses. So if your function has one single argument of type string, you can leave the parentheses out. If you want to write a comment, you do 2 double dashes. This is a comment. And this is essentially our Hello World implementation in Lua with 2 alternative syntaxes. So now that we have written this program, the question is, how can we execute it? So in my case, for example, I'm currently typing this in NeoVim. NeoVim is a text editor written in C, but it's a text editor that is configurable in Lua. So NeoVim essentially ships a Lua interpreter, and users of NeoVim can configure and alter NeoVim's behavior by writing Lua scripts. So NeoVim exposes a Lua API that we can then use to configure the look and feel, write different plugins, change how things behave. So this is one of the main advantages of Lua, that it can be very easily shipped within a bigger application. So now that I'm in NeoVim and I want to run this program, I can do a command called Lua file. So Lua file will take a file and will execute it. And as you can see here, we are executing our Hello World in Lua from within NeoVim. So if you don't use NeoVim or don't have NeoVim, it doesn't matter. You can still, of course, execute Lua programs. For this, you can use the standalone Lua interpreter that you can install for your distribution. Here you have to consult your package manager. Most Linux distributions will install Lua, will provide a Lua package. For Windows and Mac, you can download Lua from lua.org website. Now, once you have installed Lua, you can execute the Lua interpreter by typing Lua and passing a script to it. So we can create a script here which contains our Hello World, and then we can pass the script to the Lua interpreter, which will run it. The Lua interpreter also has an interactive mode, so you can actually just type Lua and it will enter a interactive interpreter where you can say something like x equals 5, y equals 7, and then you can print the sum of x and y. So this is very similar to how the interactive Python interpreter works. This is very great for debugging, for prototyping, for understanding Lua programs. You can actually use this standalone interpreter. So let's now continue with Lua's type system. So Lua has a very interesting type system, and it's very important. When you learn a new programming language, the type system is one of the most important features of it. So we will spend some time trying to understand what makes Lua so unique. And one of the key fundamental characteristics of Lua is that Lua is a dynamically typed language. This is not a surprise for scripting languages. Most or all dynamic scripting languages will be dynamically typed. In this case, dynamic typing means that only values have types, but names don't. So let's consider the following Lua example. We have a program, a Lua program here. We have a variable called x. We assign the value 5 to x, and then we print the type of the name x. Type is a function that takes an expression and returns the type of the expression. In this case, this program will print number because x has, in this particular point in time, is of type number. However, we can very easily just say x now equals to a, and in this case, printing the type of x will give us string. And this is known as dynamically typed language. This means that a single name can have different types. This is opposed as statically typed languages, where every single variable has to have one single type at most assigned to it. So this makes Lua a dynamic language. And now that we're talking about Lua's type system and types, in fact, Lua has only 8 different types. And these types are string, as we saw before. In this case, hello world with double quotes is a string literal. You, of course, also have numbers. So the type of 10.4 is number. You have Boolean, which can only have the values true and false. You have nil. Nil is the absence of a value. So if you have programmed in Java before, this is similar to a null pointer in Java. This is similar to none in Python. So it's a value that represents the absence of something. And this is very interesting in Lua. There is also tables. So Lua has actually one single compound data structure, which is called a table, and it's constructed by these curly braces. So every time that you see curly braces in Lua, this means that this is a table. Then you have functions. A function is also a type in Lua. So the type of print is function, because print is a function. Then we have thread. A thread is actually, might be confusing. A thread is actually not a hardware thread, how you might know them. A thread is actually more like a coroutine in Lua. Coroutines are functions that can yield execution and resume it later. In Python, this is known as a generator. Coroutines are interesting, but are still advanced. I consider them an advanced feature in Lua. We won't go deep into coroutines, but if you want to become an expert in Lua, then coroutines might be one of the further reading topics that you might want to get into. And there is an 8th type. This is called user data. This is a type that models arbitrary contents and size. So if you have been programming in C or C++, this would be the equivalent of a void pointer. So this is a type that you use usually when you communicate between Lua and C. So what is nil? Nil represents the absence of a value. So essentially all variables in Lua are initialized to nil, even the undefined ones. So this is something that is very strange for beginners, that a program where I say print X is actually a valid program. This is not a program that is going to crash. It's going to just print nil. for me. And this is strange because usually I'm referring to a variable that I never defined before. So x was never defined previously here, but still, since even if I have never defined, Lua will just assume that everything is nil. Another very important characteristic of Lua is that it doesn't have any dedicated integer type. So essentially everything is represented as a double precision floating point number. So as you can see here, the type of 5 and the type of 5.6 is actually the same. There is no discrimination between integers and floats in Lua. So now functions in Lua are first class values, and this is very important. The fact that a function in Lua, for example, you can construct it like this. You use the keyword function, then you pass a list of arguments, and then you write the body of the function here. Functions have to be terminated with an end keyword. So in this example here, this is a function that takes a number, multiplies it by 2. And you can assign functions to variables. So in this case, times 2 is a variable of type function. The same thing you can do here. And now we can write a function that takes another function of argument as argument. And this is what makes Lua very interesting, which is a function, it's a language that considers functions as first class values. This means that a function can be assigned to a variable, and you can also pass functions as arguments and also return functions. So functions behave the same way as an integer, as a boolean, as a string. They are a first class value. And in this case, we have a function called apply twice, which takes a function and a value as arguments and applies the function 2 times to the second argument. And what we can do with this is that we can just essentially call apply twice with times 2 as first argument and 5 as the second argument, and this will give us 20. So this is a very interesting characteristic of Lua that makes us also something like functional programming possible in some regards. So we said that Lua is a dynamically and weakly typed language. We said Lua is dynamically typed because only values have types, but names and variables don't. So when you categorize programming languages based on their type systems, you have usually 2 dimensions to consider. The first dimension is dynamic versus static. So in statically typed languages, like for example Java, every time that you introduce a variable or a name, you have to give it a type. And the type system or the Java compiler will make sure that this type is only used in valid contexts, that you are not using the type in an invalid setting. This is as opposed to dynamically typed languages where where a name doesn't have to have a type assigned to it. So you can actually, a single name can have different types during the execution of the program. And as you can see here on the left side, most, if not all, scripting languages are dynamically typed. So for example, Python is dynamically typed, Ruby is dynamically typed, Perl is dynamically typed, JavaScript. So, and of course, Lua is down here. But what makes Lua different to something like Python is that Lua is also weakly typed, which is as opposed to something like Python, because Python is a strongly typed language. And in this case, weakly typed means is that the type system is very permissive as to which types can be used in which contexts. So essentially, in this case, weakly typed languages give the programmer more flexibility as to which types can be used in which contexts, but at the same time, it opens the door for certain bugs and errors that become unnoticed. So I understand that this is a very abstract definition. The best way to explain why Lua is a weakly typed language is by looking at examples. So one of the best ways to exemplify why Lua is a weakly typed language is by looking into Lua's logical operators. So Lua has logical operators. Just like any other programming language, you want to be able to write true and false, right? And true and false, of course, evaluates to false. This works the way you would expect it to behave. You can also do false or true, which will evaluate to true. This is pretty obvious. This is how you would expect these operators to behave. You can also negate a Boolean, so true will become false, false will become true. And this is all good. This is what you would probably expect. But the thing that makes Lua different and why we should consider Lua a weakly typed language is that logical operators are not restricted to Booleans. Logical operators actually work with all types. And this is what makes Lua weakly typed, is that you can actually have something like a number and you can use that with a logical operator. So you can actually write an expression something like 5 and 6, which might not make a lot of sense, but you can still do it. And in fact, this makes Lua actually a very interesting programming language to work with. It's because you can actually use types in almost any expression. And how it works with logical operators is that in Lua, everything is true, but nil and false. So this is like the ground rules. Another very important characteristic about logical operators in Lua is that they short circuit. So if you have something like false and x, this will evaluate always to false, regardless of the value of x. So if you have, so in this case, the x will be completely ignored. It's an expression that will not even be considered, will be thrown away. A similar thing happens when you have something true and x. In this case, this expression will just directly evaluate to x. And the AND operator short circuits and the OR operator short circuits as well. So true or x is just the same as true. You don't even consider x at all. And false or x is the same as x in this case. So as I said before, in Lua you can use logical operators for all the types. So you can do something like 4 and 5. And in this case, this whole expression will evaluate to 5. It's because 4 is essentially considered true. And you will be, in this case here, which we will just essentially evaluate to 5 here. You can also see something like nil or 13. This was evaluate to 13. In this case, this doesn't seem as useful as you might think, but it allows you to, for example, compute the minimum of two numbers by doing this expression here. And this is, you can see why this is interesting. In many languages, you would require a ternary operator or an if statement to compute the minimum of two numbers. In Lua, you can actually use logical operators for this. There is also a very common idiom in Lua, which is if you want to initialize a variable to some value only if the variable hasn't been defined yet. So in this case, we want to initialize x to a value v only if x has not been defined yet. We can write it like this. And essentially, you would need an alternative syntax to this would be to use an if statement. So in this case, you would write if not x, meaning if x has not been defined, then set x to v. So these two expressions are equivalent, and you can see how the binary, how the logical operator one is shorter and more concise. And this is Lua. This is Lua. This is something that you will see all the time in Lua programs. So it's very important to understand that logical operators work with all types. Another example of Lua's weak typing is the concatenation operator. So you Of course, often want to concatenate two things. For example, you want to concatenate a string, so you can have string number 1, which contains hello space, string number 2, which has world. You want to construct them together into a single string. For this, you use the ... operator in Lua. But you can actually also use other types when concatenating. And this is, again, under the motto of Lua is a weakly typed language. So you can actually have a string and you can concatenate a string and a number. And this is the place where Python will tell you, you cannot do this, because you cannot concatenate a string and a number. This is not sound. This makes no sense. Python will force you to convert the number to a string. Lua tells you, you're good. You can do this. I am weakly typed, meaning my type system is much more permissive. And actually, you can also concatenate two numbers. So you can say 1 concatenated to 10, and this will return 110, which is interesting. This is not something that all languages will allow you to do. So now let's discuss Lua's lexical scope. So variables that are defined in Lua are defined inside a scope. The scope means where is the variable defined and from where can be accessed, right? So on a very trivial case, you would have one single scope, and essentially every name that you define in your program will be written to a global table of variables. And this is, of course, probably not a good idea, because you don't want all the variables that you define, all the names that you introduce, to be accessible from everywhere. And the global scope is essentially this. The global scope defines names. So all the names defined in the global scope are accessed from the entire program. So for example, the print function that you see here, this is a name that is defined inside a global scope. In Lua, when you introduce a name, it's per default global. For example, here we have a function called f, and the function inside of its body introduces a name b equals 4. In this case, b is actually global, because in Lua everything is global per default. So after I execute this function f and I print the value of b, I'm gonna get out 4. This means that b in this case was written in a global scope, which can be accessed outside of f. So it can access from anywhere in your program. This is probably not what you want, right? So you want to restrict the scope of your variables, because you don't want to pollute your global scope. You don't want to override something that might have been there. You probably want to, in many cases, restrict where your variables can be accessed from. So let's consider this example here. So we define two variables. So in Lua, you can define two variables by using the syntax a, comma b equals 1 and 10. In this case, a will have the value 1, b will have the value 10. And these are, as before, global variables. This is going to go into the global scope. And then I can have an if statement. So this is how you write an if statement in Lua. You ask if a equals b, then we print a. But then comes a very interesting line, which is local a equals 4. And essentially the local keyword in Lua tells the Lua interpreter that the variable a in this case is not global, but it's local. So this variable a, it's only defined inside the if body. So when I introduce a equals 4 with the keyword local, this is a completely different name than the a here. So a name only makes sense in the context of a scope. So in this case, we have A, but it's a local A. In this case, when we print A, we're going to print 4. And we're printing 4 is because this A here opaques the A that was defined at the global level. So in this case, we're going to print 4. But the interesting thing is when we actually leave the if statement and we print A and B, we are actually going to print 1 and 10. So in this case, we're actually be referring to the E in the global scope. And the reason for this is that the A that we introduce here in the local scope, its lifetime will end at the after the if block finalizes. So this is what is known as a local variable that will not longer exist or will no longer be valid after its surrounding scope ends. And this is usually what you would wanna do when you define variables. You might wanna restrict their usage as much as possible. And for doing this, in order to do this in Lua, you will use the local keyword. Usually you don't have an if statement or something that you have to define your scope. In this case, you can do something called a do block. So a do block in Lua is essentially just explicit limitation for a lexical scope. This is something in languages that you have C syntax like Java or C++ or C. This is what the curly braces will do. They introduce an explicit lexical scope. In this case, we have a do end block, and we define inside the do end block two variables, x and y, x being local, y being global. In this case, after the do end block finishes, the local variable, of course, will not longer leave, so you cannot be able to access x anymore. But y, since it's global, it will be accessible from the entire program. So its scope will be unrestricted. In this case, x is of course nil because there is no global x anywhere defined. Y will be 7. So now let's talk about Lua functions. We already talked a little bit about functions before. Essentially, a function in Lua is defined by the keyword function. Then you define a list of arguments, and then you have a function body. In this case, we have a function that computes the OR of A and B. And you can assign the function to a variable, or you can also have this syntax where you put the name of the function before the argument list. This is like a more natural syntax if you want. These two are equivalent. And then you can do f of true and false. This will return the or of true and false, which is true. But some very peculiar thing about Lua is that you can actually omit arguments. So even if f defines 2 arguments, you can actually only pass 1. And this will not be an error. This actually will implicitly initialize B as nil. And as we said before, B nil is the same as false. So this entire expression will result in A or false. And in this case will be true or false, which is true. So this is not an error, and you can actually also pass more arguments that you define. So I can actually pass a 7 here, they will just get ignored. So here you can see also how permissive Lua is in terms of if I define a function, I can pass less arguments than what the function expects. You can pass more arguments than the function expects. This will not be an error, this will be essentially either ignored or initialized to nil. So you have to be very careful when you program in Lua, in the sense that you can do a lot of stuff without the interpreter complaining. And this is one example of such cases. Functions can also return multiple values. This is actually very, very useful actually, because not every function has to always return one single thing. You can actually have a function that returns A and B or A. So you have the AND of your arguments and the OR of your arguments, and you can actually unpack. If you call G, you can unpack the result by using this comma syntax. This is something like Python uses as well, which is very convenient. In this case, you would have false and true. You can actually ignore the second value. So if you just write X, the second value, in this case, the B or A, will be completely ignored. You can actually do it explicitly. So you can use this underscore literal, which means ignore it. So this is useful because you tell other programmers and people reading your code that you're actually intend to ignore the value. And you can, as always in Lua, you can actually expand more variables than the ones you have. In this case, Z will be nil. Again, this will not be an error. So when programming in Lua, be careful that usually everything is nil. You don't rely on the interpreter to tell you that this makes no sense. One very powerful feature of Lua are closures. So closures are functions that capture the environment. If you have worked with languages like C++, this is a lambda, for example. This is why a C++ lambda would do, or Kotlin also has this. Essentially, every modern language will have the notion of a closure. And in this case, a closure is a function that captures its environment. What this exactly means, we will see now. So we are defining a function count. And the function count has a local variable called counter, which we initialize to 0. So the local function counter is defined inside this function scope. So it's only defined within this function. So you cannot access counter outside of function because it's local. But now we see a very interesting thing about count, which is count returns another function. And the function that count returns is a function that accesses the counter variable. So every time that function is executed, we are incrementing the counter by 1 and returning it. So you're having a function that returns a function, which is something that is possible in Lua. As we said before, functions are first-class values, so you can actually return functions from another function, or you can have a function as a parameter. So a function behaves the same way as any other value. And in this case, we just call the function count, and we have a name called myCounter. The type of myCounter is function because count returns a function. And now we can start to call myCounter. And the first time that we call it, this will print 1. The second time it will print 2. And the third time it will print 3, and so on and so forth. So you can actually see here that even though the counter is defined outside of this function, it's still being captured by it, because every time that you call the internal function, the counter is actually being increased by 1, and the value is being remembered in subsequent executions. And this is what makes a closure. A closure actually recognizes that this value is being referenced, and even though this value is defined outside of the function scope, the closure is going to essentially capture it inside. So it's going to take this counter and it's going to be captured inside of this function. So that every time that this function is called, you can refer to this thing. And closures are complex, I know, but they are extremely powerful. So once you start to get into Lua and you start to do some let's say, functional like kind of things, you will see that a function that's able to automatically capture its environment and capture the variables that it uses automatically, it's a very powerful feature. And Lua is superb at this. So now we have reached actually the final part of the tutorial, which are tables. And tables are the single data structure in Lua. So far we have seen numbers, we have seen strings, we have seen nil, we have seen booleans, but usually you want to have lists of numbers, right? Or you want to have some other more complex data structures. And for this, Lua's solution is called a table. And let's start with the first usage of a table, which are associative arrays. An associative array is essentially a key, it's something that Python calls a dictionary. Some other languages, or in computer science, we call this a hash table, which is essentially associative containers which have a key and a value. So essentially they store entries, and every entry has a key, which a value which is associated with a key. So let's see how this actually works. We have an empty table. It's constructed in Lua with just empty curly braces. Then we can actually create one entry in the table A, which has a key of 10 and the value B. So essentially this says for the key 10, store the value B, which is a string. You can actually have a string as a key and an integer as a value. This is perfectly possible. So in Lua, the keys don't need to have the same types and the values don't need to have the same types. This is as opposed to statically typed languages. When you define a Java hash map or a C++ map, you always need to tell it which are the types of your keys, which are the types of your values. In Lua, this is perfectly fine. Again, dynamically typed language. And then you can say, okay, give me the value of 10. With this, we use the square bracket syntax. In this case, we will print V. And in this case, when we use the key hello, we will print 100. So in this case, Lua is, I think from the syntax, one-to-one comparable to Python. This is just an associative array. And this is a very useful data structure to have. And you can use tables for this in Lua. But it turns out that you can actually also use tables to construct arrays. And an array is essentially a list of things. In associative arrays, as we saw before, you had for every value a key and a pair. Here, you don't have a key. Essentially, what you have is only values. So in this case, you have a table which has 3 values, false, hello, and 7. And what happens in Lua when you don't specify a key explicitly, Lua will assign an implicit key for you. In this case, these are going to be numeric keys. Essentially, Lua is going to start at 1 and it's going to assign false, the key of 1. It's going to assign hello, a key of 2, and it's going to assign 7, a key of 3. And I know what you're thinking. Lua uses actually one-based indexing into arrays. So actually, as opposed to the great majority of languages, in Lua, an array is indexed starting with 1 and not 0. And another thing to also mention here is in Lua, all the types on the array don't need to have, all the values in the array don't need to have the same type. So in this case, you can have a Boolean, a string, and a number. It's perfectly valid. Again, it's a dynamically typed language, so you don't need to have the same type. So as I said before, if you try to say what is the t at location 0, this will be nil. T of 1 will be false, t of 2 will be hello, and t at the location 3 will be 7. a very small example. For example, if you want to read 10 numbers from the standard input and store them in an array, you essentially have a for loop which will have a counter from 1 to 10, and then in every iteration of the loop you will write at the given location the input, the contents of the standard input. This is, for example, how you can initialize an array in Lua. So arrays are very similar to associative arrays, with the difference that you have implicit keys, and the keys are of type number, and they start by 1 up to the end of the array, essentially. Now let's talk about another thing that you can build using tables, which are records. Records are similar to classes in object-oriented programming. I don't want to say classes, it's because Lua it's in itself not an object-oriented programming language, but essentially a record is an object that has several attributes. In this case, we can define a person, which has 2 attributes, name and age, and you can assign values to these attributes. So you can say name is John and age is 50. So in this case, this behaves very similar to an object in object-oriented programming, with the huge difference is that these are pure data structures. Usually an object has, in object-oriented programming, an object has a behavior also attached to it. So an object has data, but also behavior that works with this data. So an object has methods that you can call on and so on. In this case, records are purely data. It's a way of organizing data as different fields, as different attributes. So in order to create a record, you can use the following syntax. This is syntax sugar, actually, for the following. A record is just an associative array that has string keys of type string. So in this case, you can assign a person. You can initialize it here as the empty table, and you can say the person with has a value with key name, an entry with key name and value John. It has another entry with key age and value 50, and the keys are of type string, both. And if you have keys of type string, you can actually have the following syntax, which is person.name equals John. This is the same as doing this thing above. So this is just syntax sugar when you have keys of type string. So these are records. And let's look at an interesting characteristic of tables in Lua. In Lua, tables are special in the sense that they have reference semantics as opposed to copy semantics. And what this means is very important, and we will see now with this example. So we have essentially here an x, a variable x that we initialize to a number, 5. And then we introduce another name, and we say that this name is the same as x. So when we say y equals to x, y essentially will be a copy of x. So in this case, y is a copy of x, meaning that if I alter y, x won't be affected. So if I print x and y, in this case we will print 5 and 6, because in this case y is a copy of x. However, when dealing with tables, we don't have this behavior. If I initialize a record here, x hello equals world, and I actually say y equals to x, in this case y is not a copy of x, but it's a reference to x, meaning that if I modify y, this will also modify x, because y is just a reference to it. So if I try to print x.hello, I'm going to be printing oops. It's because in this case x and y actually are pointing to the same object. So this is very similar to how a Java reference works like, or a pointer in C. This is just every time that you're dealing with tables, you have to consider that you don't have copy semantics as you do with the other types. And this is important to consider. So now let's actually do a small note on what other things you can do with tables. So in Lua, lexical scopes, so the scopes that we discussed earlier, the local and global scopes, are also implemented using tables. And in fact, all Lua global variables are nothing else but an entry into a table called _G. And essentially, if you have the following statement, A equals false, this is the same as writing take the global table _G, create an entry on that table with key A equals to false. And this is essentially just saying you have a scope and you are essentially entering values into a scope. So this is actually a beautiful thing of Lua, is that you have very little building blocks, but a lot of stuff is just implemented using the same minimal building blocks. Like a scope is nothing else than a table with value, with keys and values, and actually you can access this table in your program, and you can print the global variables. The same goes with the function print. The function print is nothing else than a entry into the global table, which actually essentially defines a function inside. So instead of calling print like this, you can actually just write it like _G print. This is exactly the same. It's a entry in a table which stores a function that you can execute. So now let's look at packages and how to implement packages in Lua. As you start writing your programs, you don't want to write everything in the same file, right? You want to essentially split your code into single modules that you can test independently, that you can develop independently, and essentially reusable units of code. And this is in Lua called a package. So let's look at an example. We have here something point.lua file, and we want to implement in this point.lua file a type called a point that we can do operations on. So essentially we start by defining an empty table called point. This is in this case a local variable. It means that this cannot be accessed from outside of the file, right? This is only visible within the file. It is defined in the file scope. And then we have essentially a function new. So when I do this syntax, it means I'm constructing a function called new, and I'm defining it inside of the point table. So you can essentially write a function into a table in Lua. This is perfectly possible. As we saw previously with the print function, that it's just an entry into the global table, you can actually create a function and write it inside a table with the key new. So this is essentially what we're doing here. And the new function receives two arguments, x and y, and it constructs a record which has two attributes, x and y, which are initialized to the two values that we passed. This is very similar to a constructor in an object-oriented language. It's a function that receives some initialization values, and it's going to construct an object with those values. We actually could make sense to include in our point type function to add 2 points. So if you consider these points to be vectors, it's actually very beneficial to be able to add 2 vectors. In this case, we will construct a function called add, which will return the addition of essentially the 2 points, right? And these are the two functions that we write into the point table. And this is where it's actually really beautiful. It's that you can actually return this table from your script. So essentially, a package in Lua is nothing else than a table. It's a table that you initialize, it's a table that you construct, and it's a table that you return. And essentially, this is the reusable unit of code in Lua. It's just a table. And if somebody wants to use our point type, what we can do is that we can initialize a variable p, and we call require. Require is a special function in Lua which is going to look for a point .lua file. It's going to source it, it's going to execute it, and it's going to give you back the table, essentially this table that we created here. And then we can just say p.add these 2 points. And essentially this is how you write reusable code in Lua. You essentially construct a table and let other people load that table using require and use it. So let's reiterate on our point example. There was something about our point example that wasn't as nice as it can be. And the reason for this is that by adding 2 points, you need to call this add function. And this add function is kind of awkward. What we would actually like to do would be to do something like this, right? We would like to use the plus operator to add 2 vectors, which is the natural way. This is much more readable. This is much better understood. How can we do this in Lua? Actually, very easy. We just have to use something called meta tables. And essentially what we have to do is we have to modify our add function in our point.lua file. We have to create a table called MT, which stands for meta table. And then we have to set a special entry in this table. In this case, it's __ add. And what this is going to do is that we are assigning a function that receives 2 points, essentially the same function we had before, but now instead of calling it add, as we did here, we are calling it __ add. And essentially, when we construct a point, what we're doing is that we are setting the meta table of our point to be empty, which is the meta table that we constructed here. And by doing this magically, we are gonna be able to just use the plus operator. So this is one way how you can do operator overloading in Lua. You construct a meta table where you set special fields, and once you do that, you can actually call the set meta table function that will assign the specification of these operators for this particular type. And that's it. This is how you can essentially do operator overloading in Lua. So that's it. There is not much more to it. You are a Lua programmer now. We have visited all the basics of Lua, and actually this is enough to start writing Lua programs right away. There are nonetheless some things that I left out because I consider them advanced features, not really features that you need to know to learn Lua or write Lua programs, but it's nice to know. One of these things are coroutines. So coroutines are functions that can stop and pause their execution, so they yield control and can be resumed later. In Python, these are called generators, and these are very useful. So if you wanna deepen your Lua knowledge, read on Lua coroutines for asynchronous programming. Lua has a really nice implementation of this. As I said before, Lua is actually very rarely used as a standalone program. Usually Lua programs are running inside a C or C++ application. So if you want to write an application that allows its users to extend or modify its behavior, it's a good option to actually embed Lua into your application, expose a Lua API that users can use. For this, you will of course need to learn the Lua C library. So Lua is actually implemented as a C library, which facilitates the communication between Lua and C, and it has a C API as well. You can also deep into object-oriented programming in Lua. So there are people who use Lua in a much more object-oriented programming manner by using meta tables and tables. You can implement things like encapsulation, inheritance, and so on. I personally don't recommend you to write Lua like this, but if you want, you can, of course. And finally, the standard library of Lua is very minimal, but also very complete. So especially if you're a NeoVim plugin developer, looking into Lua standard library is going to be very beneficial because they implement very nice string manipulation features, regex, and so on that make writing programs very convenient. And of course, if you have any doubts or questions, you can consult the manual at any time. It is online. It provides you all the information you need in case you wanna look something up while programming in Lua. And there is also a book out there by the Lua creators, an official book that you can essentially read if you want a more digestible Lua input. And that's it. So if you like the video, you can subscribe to my channel. I'm planning to do more language tutorials like this. And that's it. Have a great day.